Algebra 2, Lesson 15, Elimination. So we're solving systems of equations that have two unknowns again. We'll be starting with a practice problem for this lesson set. And instead of substituting to solve, we're going to be solving using elimination, which means that we're going to eliminate one of the variables from the equation by adding both equations together. To do this, it works best if you pick a variable that has opposite signs in each equation. Like, for example, this 4x and this negative 3x, they have opposite signs because one is positive, one's negative. That's the best way to go about it. But every now and again, you'll run into an equation where everything has the same sign. But first, we're going to go ahead and use the easy method and use an equation with opposite signs. So once we pick the x's, because one's negative, one's positive, the next thing we need to do is find a least common multiple. What will 4 and negative 3 both go into? Well, the answer is 12. 3 and 4 will both go into 12. And then we want to make this 4 a 12 and this 3 a negative 12. And the goal is to have them to have opposite signs. So first we have to turn this 4 into a positive 12, turn this 3 into a negative 12 without changing the truth of the equation. So we do that by multiplying the entire equation by a value. The top one, we'll multiply the entire equation by 3, so that way distributive property will multiply both sides of the equation evenly. And then the bottom one we'll multiply by 4. So once we distribute, this top equation gets rewritten as 12x plus 9y equals 51. And the bottom equation gets rewritten as negative 12x plus 16y equals 24. From here, what we're going to do is we're going to add the two equations together. And we'll see that adding like terms, this positive 12 and this negative 12 are going to cancel each other out. And now there are no more x's in the equation. We eliminated the x from the equation. So then we add the 9y and the 16y. We get 25y. And then 51 and 24 comes out to 75. Divide each side by 25. That equals 3. So then y equals 3. So to solve for x, all we have to do is take our value of 3, plug it into one of these equations. We'll go ahead and plug it into this bottom equation. So we'll rewrite this as negative 3x plus 4 times 3 equals 6. From here we'll simplify this. It becomes negative 3x plus 12 equals 6 minus 12 from each side. The 12's cancel. 6 minus 12 gives us negative 6. So negative 3x equals negative 6 divided by negative 3 on each side. And then we get 2. So y equals 3, x equals 2. We write our final answer as 2, 3 as a set of coordinate pair. Next, let's go ahead and solve another one. But this one we're going to solve for the y's, so that way we know what to do if we want to solve for a variable that both have the same sign. So just like the one above, once we pick our variable, we have to find a least common multiple, something that 2 and 3 will both go into. That one's pretty simple. It's just going to be 6. Now the problem is they both have the same sign. And if you remember when we did this other problem up here, the goal was to get the negative and positive to cancel each other out. But if they both have the same sign, that's not going to happen. So all we have to do is just pick one of the equations and multiply it by a negative instead of a positive number. So we'll go ahead and take the bottom equation. We'll multiply that by negative 2 instead of a positive 2. So that way this will become a negative 6. And the top equation will just multiply by a positive 3. So when it distributes, this will become a positive 6. That will give us our opposite signs, and we will be able to eliminate them after we distribute. So we'll use distributive property to multiply each equation. The top one, 3 times 3x gives us 9x. 3 times 2y gives us 6y. 3 times 23 gives us 69. And then the bottom equation, negative 2 times negative 2x gives us positive 4x. Negative 2 times 3y gives us negative 6y. And negative 2 times positive 2 gives us negative 4. So here we've got a positive and a negative. When we add, these are going to cancel. 9 plus 4x gives us 13x. And then 69 minus 4 gives us 65. So now we just divide each side by 13. And we get x equals 65 over 13. Now, why can 13 go into 65 evenly? Well, I think it can. Let's find out. 13, I'll try 5. 5, 6, oh, yep, it can. Goes in perfectly. So that is just going to equal 5. So x equals positive 5. Once I have a value for x, I'm going to substitute that into one of these top equations. We'll just go with this one right here. So we get negative 2 times 5 plus 3y equals 2. These combined become negative 10 plus 3y equals 2. Add 10 to each side. Those cancel. That becomes 12. 3y equals 12. Divide each side by 3. And y. Oop, I was off the camera. Alright, so yeah, we added 10 to each side. We got 3y equals 12. Divide each side by 3. 12 over 3 equals 4. So x equals 5. Y equals 4. We write our final answer in the form 5, comma 4. And that is it.